Simplify and state domain restrictions. Well, before we do anything, let's factor out as much as we can. Okay, so I have 1 here. I have 5p squared down here, not much I can do. Divided by, I can bring out a 9p minus 4. I can bring out a 5p squared. That leaves me with p minus 7. All right. Now that I have that, my domain restrictions are going to be any number that makes the denominator equal to 0. Okay, so I am not allowed to plug in 0 for this 5p squared because that'll make that equal to 0. Same thing with you. So p equals 0 is going to be a guy that makes that bottom become 0. Similarly, this factor 5p squared, if I were to set that equal to 0, I would get p equals 0 again. P equals 7 is going to be my domain restriction here because that makes that factor equal to 0. So my domain restrictions so far are going to be p equals 0 and 7. But I'm not done with this because now that this is division, I have to flip and multiply. So nothing happens with the first, but by flipping and multiplying, I have now brought that p minus 4 in the denominator, which means I now have a brand new domain restriction. I'm not allowed to use 4. So p equals 4 is now a domain restriction. Okay, and if you're like, well, do we still have to count 7? Yep, because if you plug in 7 into the original problem, it's not going to work. It's not going to work. So now that I'm multiplying, I can cross out the 5p squared, and that leaves me with just 1 up here times p minus 7, which is just p minus 7. On the bottom, I have 9 times p minus 4. So if I want to take that back and turn that back into 9p minus 36, I can certainly do that. But now I have my domain restrictions, and now you can see why I can't plug in 4 because I can't plug it into the answer. So I couldn't plug in 7 into the original problem. I can't plug 4 into the answer. This is how you do that problem. Not so bad, but not so great either.